Okay, so the key on all this stuff is measurement, and let me just kind of give an overview on measurement and calipers. So if you're building a house, you use a construction tape. These increments are 16, so you're accurate to 1/16 of an inch. If you're doing concrete, you're usually accurate to 1/16 or 1/8 of an inch. Then from this kind of tape, you go to a cabinet tape, and you count up the increments on here, and there are 32 in the first foot. So then this is accurate to 32, 1/32 of an inch. And then if you're still staying fractional dial calipers and fractions, right? And every little tick marks a 64th of an inch. But after a 64th of an inch, you go to thousandths of an inch. Okay? So this is a dial caliper that's fractional. And then I also have dial calipers that are in thousandths of an inch. And every little tick mark on these is to the thousandths of an inch. Okay? So you stay fractional usually to a 32nd of an inch. And then after a 32nd of an inch, you go to thousandths. So 1/32, 1 divided by 32 is 0.031. So this is equal to 0.031, and that's called 31 thousandths of an inch. Even if you have 0.15, even though that's 15 hundredths, you still talk about it as thousandths of an inch, that's 150 thousandths. Okay, so we stay fractional until about a 32nd, then we go to thousandths of an inch. Now let me explain how these caliper work. So this is a thousandths of an inch dial caliper, but you also have digital calipers that measure in thousandths of an inch as well. Okay, the first thing you do on any caliper is you gently close it, then you make sure you're in inches, and then when it's gently closed, you zero it. So you always got to zero it with the gently closed. There are 4 ways to measure with the caliper. The first, if I have a little box like this and I want to find the wall thickness, I gently close it on there. And I see it's 125 thousandths of an inch. Okay? The next measurement is on the back side of the caliper. I put it inside of something and measure. And I could get an inside diameter. So that diameter is 745 thousandths of an inch. Then the third way is I could use this piece of the caliper. If I want to measure the depth of a pocket, I push it down in there gently. And the pocket depth is 608 thousandths of an inch. Okay? And then the fourth way, this way is pretty clever. If I want to find the thickness of the bottom of this box, what I do is I find the depth of the box this way. Then I actually hold it right there and I zero it. Then I find the overall height. And that's going to be the thickness of the bottom. So you could actually use it to find thickness of the bottom without having to do addition. You could actually do all your addition and subtractions right on the caliper by zeroing it. So you could do outside, inside, depth, and then even thickness of the bottom of that box with the caliper. Again, this is a digital caliper. This is a fractional dial caliper. And then this right here is also dial caliper. Okay, so I have 6 little boxes right here. You need to get into groups of 3 or 4. Grab one of the little boxes. They're numbered 1 through 6. Grab a caliper, either a digital caliper or dial caliper, and then you have to engineer and design the top of the box. The slip fit you want of the piece to go into the box that you choose needs to be about 5 thousandths narrower than the actual inside of the box. So everybody's going to design a top, everybody's going to have a working drawing of the top. So what's the inside dimension, Cameron?
The opening is 0.753 right in here.
And then what's the box top?
The box top is 0.748 inches.
5 thousandths less. Beautiful.
Yep.